Hello everyone, and welcome to this video where I'll be taking you through a sample question that's related to the objective called Determine the equation of the tangent to a parametrically defined curve. All right, so in this, I'm going to be at Knewton.com in their Knewton Alta program, and I have a question here related to that title objective. Now I'm in the instructor mode, so you can see the correct answer already. Obviously, I will show you how that came about. Uh, and if you're somewhat familiar with the material already, I would highly suggest that you pause the video and try to work out the problem yourself, and then come back and watch me go through it, compare your work to mine, and see how well you're picking things up. All right, so we're asked to determine the equation of the tangent line at t equals pi over 3 to the curve defined parametrically by the equations x of t equals -3 times the sine of 4t and y of t equals 7 times the cosine of 4t. And finally, enter your answer as an exact answer. That simply means don't punch the numbers in a calculator and round to decimal places, just leave things as they are. All right. So remember parametric equations, right? You have the x and y coordinate of whatever location you're at on the xy plane depend on this parameter here called t. And as you change the values of t, you move to different locations on the xy plane and trace out a curve. We'll see later at the desmos.com site that these will trace out an ellipse, some oval shape. And we're going to specifically go to the moment, though, where the value of t is pi over 3. Find that point, find the slope, right? The slope, the derivative at that point, slope of a tangent line, and then we can write our equation for the tangent line. All right, so I'll go with some paper to do that. All right, so the parametric equations given, we have x of t is -3 times the sine of 4t, and the y coordinate, y of t, was 7 times the cosine of 4t. Okay, so in order to write the equation of a line, right, we're trying to find the tangent line to the curve traced out by these at a particular value of t. First, I'd like the point that we're going to be at, right? What location will we be at first? So at, the point where t equals pi over 3, I'll just plug in the x coordinate and y, plug in pi over 3 for t, find the x coordinate and y coordinate. So the x coordinate, I'm just gonna, you can say x at pi over 3, but the x coordinate will be equal to -3 times the sine of 4 pi over 3. Now remember 4 pi over 3, it's just a real quick refresher here. If you were to draw that 4 pi over 3 angle, remember pi over 3 is 60 degrees, this is in radians here. 4 of that would be 240, right? So you'd be going counterclockwise and you'd be in quadrant 3 here. There's a 4 pi over 3. And you might recall that the quadrant 3, right, both cosine and sine were negative. So this is -3 times, and the sine of 4 pi over 3 was just like, the sine of pi over 3, right? That's the reference angle, the angle it is off the horizontal, but negative. So it's, negative square root of 3 over 2. So the x coordinate is positive 3 times the square root of 3 divided by 2. And then the y coordinate, when t is pi over 3, is 7 times the cosine of 4 pi over 3. And again, the cosine of 4 pi over 3 will be the same as the cosine of pi over 3, but negative again. We're in quadrant 3. And that was a half. So this is 7 times negative half. So negative 7 halves. All right, so the point we're at has an x-coordinate of 3 times the square root of 3 divided by 2, and a y-coordinate of negative 7 halves. Okay. All right, so next, after I'll put that in a box, right? This isn't the answer yet, but it's going to help me when I write the equation of the line. Right? Next, I want the slope, right? The slope of this line, which you can call m, but this was the derivative, the slope of a tangent line. So it's typically represented as the change in y divided by the change in x, right? At an instant, right? That's why I have d instead of delta. Delta was over a period of over an interval and not in an instant. This is at an instant. So dy over dx or y prime of x, whatever. Slope of the tangent line. Now, if y and x both depend on this parameter t, and you probably saw this in earlier videos or hopefully in your reading, but this is equivalent to dy over dt in the numerator divided by, and dx over dt in the denominator. So the derivative of y with respect to t divided by the derivative of x with respect to t, which we can go about finding up here. We go back to the parametric equations. I'll do dy over dt, y prime of t first. And this would be, 7 times the derivative of the cosine of something is negative the sine of that thing, and then you got to do the chain rule as well, times the derivative of the expression inside, which is 4. And multiplying this out, this is negative 28 times the sine of 4t. All right, so that's in the numerator of the expression that will help me find the slope of the tangent line at our point. And then the denominator is, dx over dt, right? Or you could call it x prime of t. And this should be negative 3 times, and the derivative of the sine of something was the cosine of that thing, right? So cosine of 4t, and then times 4 again with the chain rule. And multiplying this out, we have negative 12 times the cosine of 4t. And when I simplify this, this is negative 4 times 7. This is negative 4 times 3. So negative 4 will cancel. You got 7/3. And you could rewrite sine of 4t divided by cosine 4t as the tangent of 4t, just to make it a little simpler looking. But there we go. This expression right here tells me the slope of the tangent line to any point on the ellipse traced out by these parametric equations. We just have to know the value of t that we're at, and we do. Right? We do know the value of t. It was given to us. They said, what is this at pi over 3? All right, so at t equals pi over 3, all right, dy over dx, or y prime of x, the slope of the tangent line, will be 7/3 times the tangent of 4 pi over 3, which, we saw already, the sine of 4 pi over 3 was negative root 3 over 2. The cosine of 4 pi over 3, all right, this cosine of 4 pi over 3 is negative half. And if you were to divide those, that would be positive square root of 3. So this is 7/3 times the square root of 3, right? Or just 7 times the square root of 3 over 3. All right, and I'll box that in as well. And we're going to put these together to make our tangent line. I'll just put them up here. Got a little more space here. Okay, so now that I know the point that we're at when t equals pi over 3 and the slope of the curve, right? The slope of the tangent there, the dy over dx. Here is our tangent line. All right, tangent line here. Now I'm going to put this in a point slope form to start. So that's, y minus the y coordinate of our point. So y minus -7/2, that'd be y plus 7/2 equals the slope, right, our derivative here. So 7 times the square root of 3 over 3 times the quantity, and then the change in x, where we go x minus, and then the x coordinate of our point, 3 times the square root of 3 over 2. And this is fantastic. This is the tangent line that we'd be looking for. All right, but if you go back, so y plus 7/2 equals, 7 root 3 over 3 times the quantity x minus 3 root 3 over 2. But if you go back to the site here, see they have you fill in the blank for it, it's solved for y. See, it's y equals. So I want to solve this for y and put it in, slope intercept form, y equals mx plus b. All right, so let's do that and see that it matches. All right, so I guess I could have gone to some more paper because I do need a little more space here. So some new paper up here. Taking this, we're going to distribute this 7 root 3 over 3, right? Distribute the slope. We have y plus 7/2 equals, 7 times the square root of 3 over 3 times x, and then minus. Now, when I multiply 7 root 3 over 3 times 3 root 3 over 2, the 3's will cancel. Root 3 times root 3 is going to be 3, the square root of 9, right? And then 7 times 3 is 21, so it'll be 21/2. And then finally, to get y alone, take away 7/2 here. So we have, when all's put into slope-intercept form, we have y equals 7 root 3 over 3 for the slope times x. And then -21/2 minus 7/2, that'd be -28/2, but 28 divided by 2 is 14, so we have minus 14 when totally simplified. And there we go. I'm going to bubble this in. This is what they asked for here, right? The slope-intercept form. They're the same equation. They really are. But this is, point-slope form. This is slope-intercept form at the end. And if we go back and look, that is exactly what's gotten here, right? 7 root 3 over 3 times x minus 14. So looks like I did okay. All right, now I'm going to visually verify this, right? Even though I can see the answer. You know, maybe they made a mistake or I made a mistake. I don't know. Let's really hammer this home and double check it. So I'm gonna go to desmos.com, a free online calculator, and enter these parametric equations as an ordered pair, right? So when you're entering parametric equations for a curve in Desmos, it's as an ordered pair. So the x coordinate was -3 times the sine of 4t, comma, y coordinate 7 times the cosine of 4t. And then I'm going to just have the t range from 0 to 2 pi, because I know it's going to form an ellipse and all that, right? There's your curve, right? This oval shape, this ellipse centered at the origin. Now, when t was pi over 3, right? I said here was the point we should be at, right? 3 square root of 3 divided by 2 for the x coordinate, comma, and then -7/2 for the y coordinate. I'll label this, and it labels it with decimals and stuff, but that is clearly on the curve, right? I'm going to zoom in, put it in the center here. You can see this point when t was pi over 3. We're at this point here, which is clearly on this ellipse, on this curve. And I hope it's obvious too that, the curve is going up to the right at this moment. So when I put the tangent line in there, it should have a positive slope. which it does, right? Our tangent line, I'll put in the slope-intercept form that we found at the end. The tangent line was, y equals 7 times the square root of 3 divided by 3, that was our slope, times x, then minus 14. Now I'll go to change the settings a bit, maybe make this a dashed line instead. But hopefully you can see, hopefully it's obvious that at this moment that's highlighted here on the curve, this green dotted line definitely points in the same direction that the curve is going in at that moment, right? And the closer you zoom into that point, the closer and closer the line and the curve look to being each other. They're basically the same. They're definitely pointing in the same direction at that moment. So we do have the correct tangent line. All right, wonderful. And hopefully you did all right. And watching me do this one here helps you when you do similar problems on your own. And thank you very much for watching.